Hello viewers, welcome to the second lecture of Data Communication and Network. Now let's see the topics we will cover under this section. The first topic will be error detection and correction, under which we will study about nature of errors. The second topic we will see, that is CRC, and the third topic we will discuss is Hamming code. Starting with the first topic, error detection and correction. Data link layer uses some error control mechanism to ensure that frames are transmitted with a certain level of accuracy. But to understand how errors are controlled, it is essential to know what type of errors may occur. There may be three types of errors. The first type of error we will see is single bit error, in which a frame there is only one bit anywhere though which is corrupt. The second type is multiple bits error. Frame is received with more than one bit in the corrupted state. And the third one is burst error, in which frame contains more than one consecutive bit corrupted. Errors in the received frames are detected by the means of parity check and cyclic redundancy check, which is called CRC. Well, in both cases, a few extra bits are sent along with actual data to confirm that bits received at the other end are same as they were sent. If the counter check at receiver end fails, the bits are considered corrupted. Now, moving to the second topic of today's lecture, that is CRC, which is also called cyclic redundancy check. It is a different approach to detect if the received frames contains valid data. This technique involves binary division of data bits being sent. The divisor is generated using polynomials. The sender performs a division operation on the bits being sent and calculates the remainder. Before sending the actual bits, the sender adds the remainder at the end of actual bits. Now, actual data bits plus the remainder is called a code word. The sender transmits data bits as code words. At the other end, the receiver performs division operation on code words using the same CRC divisor. If the remainder contains all zeros, the data bits are accepted. Otherwise, it is considered as there some data corruption occurred in transit. Now we will start the third and the last topic of today's lecture, that is Hamming code. It is a set of error correction codes that can be used to detect and correct the errors that can occur when the data is moved or stored from the senders to the receiver. Now here comes the redundant bits. Redundant bits are extra binary bits that are generally generated and added to the information carrying bits of data transfer to ensure that no bits were lost during the data transfer. The number of redundant bits can be calculated using the following formula, where R is equal to redundant bit and M is equal to data bit. Here 2 divided by R is greater than or equal to M plus R plus 1. Here comes the parity bits. A parity bit is a bit appended to a data of binary bits to ensure that the total number of ones in the data is even or odd. Parity bits are used for error detection. There are two types of parity bits. First one is even parity bit and second one is odd parity bit. In the case of even parity, for a given set of bits, the number of ones are counted. If that count is odd, the parity bit value is set to 1, making the total count of occurrences of ones an even number. If the total number of ones in a given set of bits is already even, the parity bit value is 0. In the case of odd parity, for a given set of bits, the number of ones are counted. If that count is even, the parity bit value is set to 1, the making of total count of occurrences of ones an odd number. If the total number of ones in a given set of bits is already odd, the parity bit value is 0. Now thank you. See you in the next lecture. Hello.